just a brief introduction about the SF6 monitoring. Talking about SF6 in GIS, SF6 gives basically the electrical insulation in GIS, and in the breaker compartment, even the arc-quenching capability. But these capabilities are strictly related to the SF6 gas density. For this reason, gas monitoring is primarily used to make sure that a sufficient quantity of SF6 gas is present, is provided to meet the requirements of the OEMs and GIS functionalities in order to avoid unexpected failures. Secondly, GIS SF6 monitoring is used to optimize the maintenance strategy. And last but not the least, as a third point, SF6 monitoring is useful to satisfy even the environmental rules about SF6 leakage control. The main features of the gas density monitoring system is to provide a permanent output signal that can be used for trendings, for example, about diagnostic requirements, and for the threshold alarms. We have two types of thresholds to level. First is the warning thresholds, with to inform that the gas has reached a low level of density. The second typically is a control signal used to block the switchgear when the density reached the minimum density needed to ensure the right equipment operation. To reach the second threshold, so there are several technologies that includes, for example, pressure switches, gas monitoring with a reference gas, temperature compensate pressure gauges, or a sensor to measure the density, the direct density measurement. We normally use SF6 density sensor in our system. We can have several type of system. This is an example with some sensor provided by Vika Traffic Vaisala, and we normally are in charge for the system integration of this kind of sensor. It can be analog digital sensor. In this case, the measurement is taken not similar with the discussion we had with circuit breaker, so but is taken on periodic basis after a few 10 of seconds or every some minutes. So in this case, not related to an open or a closed commands or an event. In this case, we can create a trends, for example. All SF6 sensors are connected to a gas hub. Here an example of the gas hub with the IP66 or 68 again protection degree. This is capable to collect up to 64 sensor. In this case, other design are available. We have connection through fiber optic or Ethernet to a central unit, or the SF6 hub can communicate directly to a substation SCADA. We normally transmit instantaneous pressure values, the leakage values, the trends, and even the alarm prediction. If requested, we can even communicate and elaborate the dew point calculation and values for the humidity. Here an example similar to the previous ones of an entire SF6 monitoring system with 256 sensor. Every hub is equipped even with a local memory and processing capability, web server, and other features. We are at the end of this presentation with the last part relevant to the integrated architecture, the integrated HMI. As you can see, we have, as we said, circuit breaker or disconnect or ethane switch monitoring, partial discharge monitoring, or SF6 monitoring. We can have different type of sensor here for the circuit breaker, or antennas for PD, and density or pressure sensor installed on the GIS. We can acquire locally through GIS monitoring hub that is normally installed close to the GIS, and again with the onboard data storage capability, so the data can be visualized and with a common laptop, for example, using the embedded web interface, or the PDFs can be connected to the central unit. We can have all the information. Here we can see two examples of layouts. The first one is distributed architecture. When we have several GIS monitoring hubs, that can be with only partial discharge or a combination of partial discharge SF6 or circuit breaker functionalities that are connected through fiber optic to the central unit, or on the bottom, a centralized architecture where all the sensors are centralized, are connected to the central unit, where we install even all the acquisition units needed to guarantee the monitoring system performances. In the central unit, here you have an example of 19 inches rack cabinet that contains the server, the software, watchdog, we can have UPS, we have a full redundant hard drives and power supplies configuration. This is to ensure the maximum reliability. We have a monitor, printer, a keyboard, mouse, everything needed to our operator. This configuration is available not only on the physical server, but is available even in the virtual machine environments that can be installed in existing hardware. And the same solution is available even as a cloud service. We integrate self-diagnosis in the system. Cabinets or even the rack are temperature controlled, can be installed even outdoor. And we have 61850 protocol, 104 OPC UA, DMP3, and many other protocols available on this system. The last part, just to share with you some pages of the full integrated web-based HMI. Here in the example, you have the home page with the customer decide to have a multiple base home page. So multiple bays are reporting on the dashboard, and we have the aggregate status of the alarms related to the, as you can see here, the PD activity, the gas SF6 alarm, or the circuit breaker alarm. We have on the right the parameter 3, where every parameters acquired by the system is available to be visualized in the graph form on a table, and the customer can decide to select one or multiple parameters independently. And here we have an overall alarm. This is another example with a single bay dashboard. Again, we have CB, SF6, FPD alarm, and shortcuts to display graphs of the alarms or about the parameters. On the previous two slides, we have seen the aggregate indication of the alarms, but look in here, we have the alarm details starting from the left. We have, for example, for each phase, alarm according to the close time, I²T, the closing velocity, the open velocity, and all the heater current and SF6 density, etc., according to the modules that are integrated in the system. And on the right, we have the value, the real-time values of the SF6 density in this case, or the feeder current, the breaker status, and etc. Embedded and customizable graphs are available for all parameters. In this example, you have 4 graphs for the peak motor current, open time, open velocity, and the heater current. You can have for partially charged, SF6, and etc. Here you have the table view of the SF6 and the current value, the alarms, the first level, and the second level of alarms for the SF6, the refill level, and the lockout alarms. And you can even visualize the trends, the individual trends for the SF6 sensor. Every parameter and threshold can be set in the dedicated page. If you have the privilege to do this, the power user or admin privilege, and you can even have a look on the waveform analysis with the ComTree view feature that is integrated in the system. Surely you have all the alarms list. You have the possibility to filter according to the event type, location, timestamp, and etc. Gentlemen, we are at the end. Sorry, took a few minutes more about our discussion. This is our closing and last slide. We start our presentation discussing about strategies to mitigate risk about GIS, and thanks to the global monitoring system based on SF6 monitoring, circuit breaker, and PD, we can have a better visibility of the status of the GIS. We can reduce the failure. We can face with the 80% of the failure modes. We can have a better understanding of, in general, the risk as key factors, let me say, to improve our mitigation strategies. This is the hand. Thanks a lot for your attention. These are my contacts. Feel free to reach me for any further clarification or information you might. Thanks you all for your attention to having attended to our webinar today, and I hope to see you soon.